Okay, and our last simple machine, the screw. And I'm going to take just a second here to kind of talk about what a screw actually is. What it is this shape right here. This is an inclined plane that we've literally wrapped around a cylinder. That's really what a screw is. So this length here would be our DE, and this height here is our DR. That's how we come up with our formula for IMA for the screw. You don't need to write that down, that's just kind of how it works. Some important things about this is, like if I have a screw and I use a screwdriver, I use a rotary motion. I turn it, that's rotary motion, but the screw moves in a linear motion. That's what it says here. It's a threaded fastener. We call these threads up here. We can get a really large MA out of it. That means that we won't have to put a lot of force down here to get a lot of force up there. But we do lose a lot of our force to friction here. This distance between two of these threads is called the pitch. We're going to see that, we saw that back when we were doing IED, and we're going to see that in our screws. I'm going to show you how to find that on our screw notation. So here's how you read thread notation. You probably remember this from IED. Every screw that we put in has 3 numbers to it, and this is what you need to remember. This first number is the diameter we're talking about, and it's the diameter of the threaded part. It's not the diameter of the head, it's the diameter of this part here. This middle number is our threads per inch. And I'll tell you how to get to the pitch from the threads per inch. And finally, this describes how coarse or fine our pitch is. We don't need this number for our calculations. We just need these first 2. So to find the pitch, here, if this screw here is 13 threads per inch, if there's 13 threads per inch, then the pitch is 1/13 of an inch. You basically take the reciprocal of this number to find the pitch. So the pitch is just 1 over the threads per inch. That's all you do. You take this number and put 1 over it to get the pitch. And then it asks us the question here, how far will a screw with 13 threads per inch move if we turn it 1 rotation? It'll move 1/13 of an inch. That's how far it moves. So I have to turn it 13 times in order to get it to move 1 inch. So I'm going to leave this where we can see that part right there while we look at our IMA. So again, it's DE over DR. Well, our DE is 1 rotation. If I turn it 1 time, how far does it go? Well, it goes the circumference of this bottom part here. And our formula for circumference is 2 pi r, or we can think about it as pi d. And the pitch is always 1 over the threads per inch. So in this case up here, my threads per inch is 20. So my bottom number here is going to be 1 over 20 for my pitch. Now the top is just a little tricky if you don't catch this little subtle thing. This problem here says that the effort I'm applying, I'm not applying it right here. I'm applying the effort out here at the end of a 8-inch long wrench. So when I'm figuring the circumference of the effort, it's actually a radius here of 8 inches. So when I do circumference, I need 2 pi, and the radius is 8 inches long. So always remember here, when we're talking about circumference, this is the circumference of the effort, and you have to be careful where you're applying the effort and what the problem's asking you for. So then I've got 16 pi divided by 1 over 20, And you want to be careful if you're putting this in your calculator and you're not making a mistake. I would actually suggest doing the 1/20 first and converting that over to a decimal so we don't make a mistake. 1/20 is 0.05. This I'm not very likely to make a mistake with. 16 times pi, 3.14, then divided by 0.05, and I get 1004.8 as my AMA. Remember what we said on the previous page. We're going to get really ginormous MAs on this because we're putting such a long effort arm on it. Okay, so let's do our example problem. Here's our example problem. So here I have a 1-inch diameter screwdriver, and a student in lab is using this kind of screw to fasten two objects together, and I want to know the mechanical advantage. So first I'm going to draw this out. I have a little screwdriver. Isn't that cute? And then I've got a little screw down here. The screwdriver has a diameter, remember that's our symbol for diameter, of 1 inch. And then down here, my pitch is 10. So if I'm going to find my IMA, it says the IMA of the screwdriver and the screw. So I'm going to put these together to find, if I'm putting my effort up here, what is my IMA of this whole thing put together. So this is circumference over pitch. Circumference is going to be up here where my effort is. So that's pi d over 1 over the threads per inch. Pi, my diameter up here is 1. My thread per inch is 10, so this is 1 over 10 on the bottom. So on top I just have pi, and on bottom 1 divided by 10 is 0.1. Divide that in your calculator, 3.14 divided by 0.1, and we get 31.4 is our MA. If I put just 7 pounds of force up here, FE equals 7, how much force am I getting down here at the bottom, my FR? Well, my AMA is FR over FE. AMA is the same as this, 31.4. FR, that's what I'm looking for. FE is 7 pounds. Multiply these together, and I'm getting 219.8 pounds of force. Again, we talked about screwdrivers a little bit when we did wheels. We're going to see very large forces because we've got very large MAs here. That's it.